Okay, I'm back, and now we want to talk about the ocean floor. And this particular picture is a very old picture. This dates back to the 1970s when I was in elementary school. And I was very fascinated by this picture. So this is put out by National Geographic, and it shows what would the oceans look like if you drained all the water out. And I thought that the bottom of the ocean floor would be flat, like a pond. If you drain the water out of a pond, it's pretty flat. But look at all the different stuff that is on this picture. First, you'll notice the line that goes down the middle of the Atlantic Ocean, and you see it goes in between Europe and North America, and then it also goes in between Africa and South America, that kind of a zigzag line there. That's a mountain range. That mountain range is as tall as the Rocky Mountains, but yet it's buried under about a mile of water. Also, these mountains are volcanic. So there's a volcanic island or volcanic chain of mountains that goes in between North America and Europe. And then you also notice that this chain of volcanic mountains, it stretches all around the earth like the seams of a baseball. So why would there be mountains in the middle of an ocean? Then another thing I noticed was that over there in the western Pacific, you have these trenches. Trenches that are so deep that you could take Mount Everest and put it in the bottom of one of these trenches and it would not stick out of the trench. So these trenches are tens of thousands of feet deep. So why would there be trenches in the western part of the Pacific Ocean, but they don't seem to be in the Atlantic Ocean? Another thing that I noticed was that you've got this mountain system that runs down from Alaska, becomes the Rocky Mountains on the western coast of the United States, and then it turns into the Andes Mountains on the western coast of South America. Why are there mountains? Why does it make a linear thing that goes up and down? But when you go over to Europe and Africa and Asia, the mountain system is going sideways. So, what about earthquakes? So what causes earthquakes? What causes volcanoes? What causes mountain building? So all of these things are going to be explained through the use of plate tectonics. So plate tectonics is very important. Plate tectonics is the most important concept in geology. If you were talking about physics, what's the most important thing in physics? Well, probably quantum mechanics, general relativity, electromagnetic field theory. So those are the key concepts in physics. Okay, when you talk about the chemistry, it was the discovery of the atom and the periodic table of elements. When you talk about astronomy, what we're talking about, it's probably the Big Bang Theory. So where did everything come from? And in biology, probably the most important thing, it was the discovery of the cell, and then the discovery of DNA, and then how DNA eventually makes proteins, which makes your cells of your body. So the main thing I want you to get is that plate tectonics is very, very important in geology. It's going to be used to explain a lot of different things. So the idea of plate tectonics is that the Earth is broken up into plates. So the uppermost part of the Earth, the lithosphere, the solid part of the surface of the Earth, is broken up into individual plates. There's about 12 of them. And you can see that the North American continent is part of the North American plate. So you have the North American continent and part of the plate that goes underneath the Atlantic Ocean. Then on the other side of it, you've got the other side of the plate that makes up the bottom of the Atlantic Ocean and Eurasia. So that's going to be called the Eurasian plate. You've got the African plate, which is the African continent, and the ocean floor that surrounds it. So, but some of these plates are purely continental, like the Saudi Arabian plate. It's made of nothing but continental lithosphere. But then you've got something like the Pacific plate, which is completely made up of oceanic plate, the stuff that's underneath the ocean, the lithosphere that is underneath the ocean. So some plates are pure ocean, some plates are pure continent, other plates are a combination thereof. Now those plates can do different things. So if you look carefully on that picture, you'll notice that at some places the plates are being pulled apart, and then at other places the plates are being pushed together, and then other places the plates are sliding past each other. So that's what we want to talk about in our next segment.